Hello, good morning, friends. Today our topic is stack data structure. Before going to the stack data structure, I would like to revise the definition and the types. These things you have learned with one task called 1 minute paper already. Just I would like to revise it. A data structure is a specialized format for organizing, processing, retrieving, and storing the data. That means, suppose there is a given a problem, we need to identify which data structure is required for that problem so that we can store the data, retrieve the data, and process the data in efficient manner. There are different data structures. All the data structures will not work for each and every problem. It depends on the type of the problem you have chosen. The very basic data types are a primitive data structures. You can call data structure and a data type in a synonym like primitive and non-primitive, or else basic data structures: integer, float, character, and pointer, etc., etc. These can able to store one unit of data. Unlike integer, array will store series of data. Unlike character, string will store series of character data. And linked list, stack, and queue. Array, linked list, stack, and queue, you can call them as a linear data types or linear data structures, where the data is stored in a sequential format. If the data is not stored in a sequential format, then it is a non-linear data structure. Example is tree and graph. Here we have a discussion on arrays and different types of arrays. Single dimensional array, double dimensional array, multi-dimensional array, etc., etc. And linked list we did not touch it till now. Now we move to the stack and queue data structures. I think these are entirely new for us. How a stack can be created, how the data value can be inserted into a stack, how data value can be removed from a stack, how we can see all the elements in a data structure called stack. All these things, all these operations we must learn theoretically, and along with C program or any other language program also we need to develop for the stack. Not only stack, for all the data structures. This is a user defined function. The main function and user defined function, capital A. These will be organized in the memory as a code, stack memory, and heap memory. Here all the variables are stored in a stack format like this. Now come to the exact definition of stack. You must remember this definition. Stack is a derived data type. That means I told you already, there are two types of data types: basic and derived, primitive or non-primitive. So stack is a data type or a derived data type which follows the principle of LIFO. LIFO. That means last in, first out. Last in, first out. You see, in operating system like Windows, here apps you are using, whenever you recently I have used Microsoft Teams, that's why it will be in the top. Suppose if I used another app or application, it will be comes above the Teams. That means each and every time whatever the new one comes, which will be added to the up topmost of the list. This is the best example. Operating system uses a stack. This is not this is bubble with 3 saga, which I used very long before. So that's why it will goes down. Whatever I use the application, that will comes onto the top. Like SMS in a mobile, SMS also the same. Suppose the new message comes, which will be lays on the top of the list. So the terminology we call it as a TOS. That means the top of the stack. Okay. Now the major two operations are push and pop. Simply say, push is an operation performed in stack to insert an element. That means if somebody has inserted an element into a stack, we call that operation as a push. If we remove an element from a stack, it is called a pop. Suppose you see this example. There is only one element. That means in the stack we have pushed A. Then there will be only one element. Suppose if you apply again push operation B, then it will be onto the top of A. If you apply push of C, then A, B, C, and that means on the top of B you can have C. Suppose if you want to pop, then that every time the topmost one should be popped. What is the topmost one? C. If C is popped, then A and B will be remained. If you again apply pop, then the recent one is B. So B will be pop. So now you are remain with whatever you have in a first position. If you apply push of D, then this element will be on the top of A. These are all the examples for push and pop operations. Again, I want to repeat. This is push operation. We inserted a element called A. Suppose if you push B, on top of A we push B. Suppose you push C, on top of B we push C. Now you please wait at this point. Which is the recent in? That means in means inside. That means recent means last. What is last in here? The last in is C. Which will comes out first? So last in, first out. So we'll pop C only. You cannot pop B at this point. You cannot pop A. Which is the last one? That only can be popped. So last in should comes out first. So last in, first out. That is the logic here. Last in is C, which comes out first. So we are learning about stack. Here I have shown in a real-time scenario where the stack can be useful. These two are the real-time scenarios. One is memory management, another one is the function calls and the main function, how these two can be organized in a stack data structure. So whenever we say stack, you should remember it is a last in, first out, LIFO. That is the first point. Second point is TOS. That means top of the stack. That means it is a reference used to add and remove the elements. And two operations, main operations are two. Push an element into a stack or insert an element into a stack called push operation. Delete an element from a stack called pop operation. This is one simple example. Now, what is exactly ADT? ADT means abstract data type. Abstract data type. It is a representation which exists for all the data structures. Suppose, for example, we are learning now about stack. Here, ADT name can be replaced with stack. It is a 3-compartment box. ADT is nothing but a 3-compartment box, which is a representation for a data structure. By seeing into a ADT, one can know about the data structure. Here ADT name is stack. Objects are variables. That means a stack is a variable. TOS is a variable. The elements which we insert into a stack are also variables. All those things we can place in the objects compartment. Functions means what are all the operations you want to perform on stack data structure. We can push an element into a data structure, call a element into a stack called push operation. We can delete an element from a stack called pop operation. So we can see the elements by display operation. And we can check whether stack is empty or stack is full. Fine. These are all the functions you can place in the third compartment. Now, totally 3 compartments. This is the representation used to know about the any data structure. That means for if you consider a queue data structure, there exists another ADT for queue. If you consider a tree, you can have one more ADT. Every data structure has its unique ADT. In order to understand what are all the involved variables, what are all the involved operations or functions related to the specific data structure, whatever we are representing. That is called ADT. Friends, don't confuse with the stack. As of now, so this is a stack data structure, suppose. Yeah, so I will place here only. This is better. Right. Don't confuse with stack data structure. As of now, right now, stack is nothing but array only. So this is an array. Here, this is the 0th element. This is the first element, second element, third, fourth, fifth, sixth. Likewise. Zero, 1, 2, 3, 4, 5, 6. That means the index of this one is 0. Here is 1, 2, 3, 4, 5, 6. Right? That means here maximum size is 6. Please understand and write down the points here. Maximum size is 6. So in a 0th location, there is an element called 7. Here 99, 9, 3, 5, 2, 90. That means here 0, 1, 2, 3, 4, 5, 6. Here maximum size is 6. If these are all the elements are not there, suppose here this is 7. Here TOS is 0 because index of 7 is 0. Then TOS is 0. Now if you push an element 6, then what is the recent element? 6. What is the TOS? 1. Because here 0, here 1. Index is 1. Suppose if you push 3, the recent element is 3. TOS is here 0, 1, 2 is the TOS. Suppose 6, 66. 1, 2, 3, 4. What is the top element is 66. TOS is 0, 1, 2, 3 is the TOS. 3 is the TOS. Suppose you inserted 34. So 34, recent element is 34. TOS is this point 0, 1, 2, 3, 4 is the TOS. Here, suppose inserted 8. Recent element is 8 and TOS is 5. And remember, maximum size is 6. Suppose we entered 0. So here TOS is 6. So we assume that maximum size is also 6, isn't it? So TOS is nothing but index of the array. Don't confuse. So if TOS has reached maximum size and greater than or equal to the maximum size, if it is the case, we cannot do the operation called push. Why means stack is overflow. Stack is overflow. That means stack is filled with all the elements. Stack has reached the maximum size, so you cannot do the push operation. Suppose the stack is not reached the maximum size. TOS is at here. TOS is at this point. That means 0, 1, 2, 3, 4, fifth point. TOS is at fifth point. Element is 8. Suppose I want to insert a new element now. Then The name of this array is stack only, like how we do a of 20, a of 20. Like here it is a stack. Just I named it as a stack. I named it as a stack. So the name of this stack is stack of 6. Stack of 6. So now TOS is at the 5th position. Now I want to insert an element called 0. So how I can insert is equal to 0, not 0, 10 I want to insert is equal to 10. Before, now the top of the stack is 5. Top of the stack is 5 because 0 here. Now top of the stack is 0. Here 1, 2, 3, 4, 5. Recent TOS is 5. First we need to do TOS plus plus. So TOS plus, if you apply TOS plus plus, then TOS will become 6. So 10 will be stored in stack of 6. So we need to place 10 here. TOS will become 6. That is the push operation. Fine. Come to pop operation. Here is the case. This is a stack with some elements. Consider a stack without any elements. No element is there in the stack. Then what is the TOS value? If we place one element here 11, then TOS will become 0. You place the element 12, TOS will become 1. But you did not place any values till now, TOS will be a -1, -1. So if TOS is less than 0, then the condition is called stack empty. You cannot do the pop operations. Simple logic. If no elements are there, how can you pop? Okay. Suppose if elements are there, here you see elements are there like this. Then what we will do is we identify the TOS. What is the TOS at this point? 0, 1, 2, 3, 4, 5, 6 is the TOS. That means the top of the list. 6 is the TOS. 6. So stack of 6. TOS means 6. Stack of 6 will be moved to A. So 10 will be moved to A. And 10 will be returned. That means 10 will be deleted. 10 will be deleted. Then TOS will become minus minus. That means TOS will become at this position. That is 0, 1, 2, 3, 4, 5th position. Instead of 6th, we will do the 5th. Now TOS is 5th. If you want to do again pop, you can do the pop operation. What is the TOS? 5. So stack of 5 is equal to A. What is the stack of 5? 5 of, what is the element inside of 8? Inside of 5, 8. So 8 will be moved, placed in the A. This is here left to right. I think you know this. We have learned in previously. This value will be stored in here. Sorry. So this left value stack of TOS will be stored in A every time. So A will be deleted. So 8 will be deleted. So TOS minus minus. So TOS value instead of 5, we can do, this is the TOS value. That is 0, 1, 2, 3, 4 is the TOS value. What is the value inside 4? 34. That is the way we can apply the stack operations. One is push operation, another one is pop operation.